What's up, everybody? Yo! Okay, hi guys. So my name is Mira. I am the vice president, one of the vice presidents of IEEE, UTD. I am a junior studying computer engineering. Quarantining is a lot. Oh, okay. So yeah, it's definitely been a struggle. But yeah, anyway, so today we have a workshop for you guys. We're going to be putting together a little Cyclone game. So if you guys have ever played those like arcade games where the lights spin in a circle and you have to hit the button when the light is on like a certain color, that's basically what we're going to be building today. So let's go ahead and take a little preview of how this game is going to work. Okay, so here I've built it. I've built it using TinkerCAD. So we'll start by setting up a TinkerCAD account. So you should start by doing that. Go to tinkercad.com and start setting up and signing in for an account. That way we can get started in building this. But you can also, if you have all the supplies, you can build it by yourself at home. The things you'll need today are an LCD screen, 9 LEDs. A breadboard would be helpful. You'll need like 11 resistors, a button, a potentiometer, and then an Arduino Uno. But today we're going to be building it in TinkerCAD. So if you don't have these supplies at home, you can always simulate it online, and that is what TinkerCAD is, which is really cool. So today we'll build this little Cyclone game. Just to demo it for you, I'm going to start the simulation. And okay, so I built it upside down. So you can't see the rise and level right side up, but that's okay. We'll build it up today. Okay, so I'm going to zoom in here so you can see, but you can see how the lights are going back and forth. Right now I'm at level 1, so it's going at a very slow speed. And it's supposed to, whenever you hit it on the red button, it tells you that, I don't know why it's broken. Okay, sorry. That must have broken it somewhere. But basically, whenever you hit the button on the red LED, it's going to tell you a level up, and then the lights will speed up as you go along, and you can get to higher levels. And it's just a fun little game that you can play. And yeah, we're going to be building that today. So let's start by going to TinkerCAD. Oh, TinkerCAD. And so after you've signed in, you'll get to this page, which is your building page. You just click on your profile and then you can go to your design. So today we're going to build a circuit. So we're going to create a new circuit. And it comes up with a little fun name for you. But we're going to change this to Cyclone Game Technical Workshop. You can name it whatever you want. Cool. So let's go ahead and get started. So again, the components that you're going to need are an Arduino here. So you can just type into the components area here, and you can pull up any components that you need. So here we're going to pull up an Arduino, and you can click R on your keyboard to rotate the pieces. I'm going to rotate it this way since I built it upside down. This time I'm going to build it right side up. Okay, we'll need a breadboard. Okay, so we'll bring out this breadboard. We'll need an LCD. So the one that they have is a 16:2 screen. And this is just good for our purposes. So let's just place that near here. Okay, we'll also need a potentiometer. Okay, we'll just put that on the breadboard. We're going to need a button. Oh. Okay, here's a button. Then we'll need 9 LEDs. So let's pull out a bunch of LEDs. I'm going to place them right here. I'm going to Control V or Control C, Control V, so I don't have to keep dragging it. We need 9. There we go. Okay, so let's actually move these down just a little bit because we want to be able to see our button up there. Okay. Awesome. And then we're going to need 11 resistors or so. Oh, my bad. Okay, so we're placing the resistors here on the anode leg. Oh, there we go. You can see that they're, oh my gosh. Okay. Oh, sorry. Yeah, here all of the resistors are on the short leg, and then all the resistors connect to ground. And we're going to set the long leg, which is the anode, to each of the pins that will connect to the Arduino. So we're going to go ahead and set these on the short leg, and then we're going to set them to the ground. So Control V, Control C, Control V to copy these over. Oh, actually, let's go ahead. We're going to change the resistance to 220 ohms for all of these resistors. This is so TinkerCAD actually lets you simulate the brightness of all of these components, which is really cool. So, you can change the resistance and you can change the brightness in TinkerCAD itself. By the way, we're going to be putting in a sign-in sheet about halfway through the workshop, and you'll be able to sign in then to get your class credit. Okay, cool. So now that we've set up all of our resistors, we're going to need 2 more resistors. We're going to have one that's going to go for the LCD. So in addition to the potentiometer, which is a variable resistance dial, basically, we're going to also have another resistor going to the LCD display, and that will be placed in later. But we're going to go ahead and just put that in. That's going to go from the 5 volts. And then the button itself is going to need a resistor, and the button resistor is going to be going to, sorry, you can't really see, but it's also going to the ground. So I'm going to put in a resistor that's going to ground. All right, so what we want to do first is make sure that all of our things are going to be connected with power and ground. So how you put wires into TinkerCAD is you just click on a node here, and a wire will come out, and then you'll be able to connect it to whatever you want it to. So here we're going to have this 5 volt connection go to the 5 volt here in TinkerCAD. And then if you click on the wire again, there you go. You can make another node, and then you can help clean up your lines a little better. Oh, sorry. Okay, I will slow down. All right. Okay, so there you go. There's red. Yeah, so sorry about that. Yeah, so here you go. Take some time to copy in all of the components that you'll need for this workshop. After you get all this done, we'll continue. But right now, what I'm just doing is wiring the ground and the power to my breadboard so that I have those connections established. Make this wire black so you can double click. There you go. So pretty. Okay, and then I also want to connect them across the channel just to make sure that this side is having the same power and ground as this side. So I'm going to go ahead and connect this node all the way over here. We'll make this color red as well, because that's our 5 volt. And then let's connect our grounds together. I'm going to move this resistor over actually. This potentiometer over. Oops. Okay, and then let's connect our grounds. Okay, so now that we have those all connected up, this is a way for making sure that all of the components are connected in the same circuit and all connected to the same ground. So this is just to make sure that the board and everything will be connected the same way. Yeah. Okay. So one thing we'll need to connect first is the potentiometer, also to power and ground. The potentiometer has 3 legs, and the resistance comes out of the middle leg, which is the wiper leg, as it says here. And then you have terminal 1 and terminal 2. So here our terminal 2 is going to be connected to ground, and our terminal 1 is going to be connected to 5 volts. So you will do the same here. You just click on the node, and you can connect it to where it needs to go. This is our 5 volts. Oh, sorry, this is terminal 2. So we're going to connect this to ground. And terminal 1, we're going to connect to 5 volts. This is red. Okay. So that's the power and ground for the potentiometer. We'll need the power and ground for the button as well. So here we have one of the button legs is going to 5 volts, and the other is connected to the pin. And on the opposite side, you'll see here we have this terminal on this side connected to power. However, this terminal on this side is connected through the resistor to ground. So terminal 1 here is connected to ground. Terminal 2A is connected to the resistor, so it's like the opposite side. That's what we're going to connect. So we'll do the same here. So this one will have the terminal connected to the resistor. And the breadboard doesn't have quite as many spots, so you can't have separate wires. But if they're connected to the same spot, it still works. So you should be fine there. But all we're going to do is connect this side to our 5 volt, just like it is here. Here I have it going through the leg. It's not connected to any other spots except for this node right here and this node here. It's just more confusing to see this way, so I've drawn a line this way. It is less organized this way though. So yeah. Okay. So these are all our power and ground connections for the breadboard component. So let's move on to the LCD components. We want to connect all of these as well. So here we go. Okay. So here we have a ground and VCC for the LCD display. So these we're going to connect directly to the ground and VCC of the breadboard. So let's this out. Just make it a little neater by adding. we'll add the extra node there, and we'll just color code this to black so we can see that it is going to ground. And here we'll have our VCC connected to the 5 volts. And yeah, since they're connected through this 5 volts, and then this channel is connected to this channel will also be connected to this 5 volt pin, and they'll all be on the same channel. Okay. So I'll just give a moment for everyone to catch up because we have all our power and ground connections set up. We have all of the cathode legs of the LEDs connected to ground. All of the anode legs are going to be connected to pins. So they're not going to be connected directly to the 5 volts. And then we're saving this extra resistor for the LCD screen for later. Okay, so go ahead and continue our connections. Okay, here on the LCD we have 8 different DB pins here. These are the digital pins, and they help you write to the screen. Here we're going to be using 4 of the pins. So I'm going to be connecting the first 4 digital pins, the last 4, D4, 5, 6, and 7. These are all going to connect to the digital pins on the Arduino Uno. We're also going to connect the RS pin and the enable pin, and those are also going to be written to the digital connections on the Arduino Uno. These are all just going to help set up with our LCD library. Arduino has an LCD library, so we don't have to worry about setting up each individual pixel on the LCD screen, which is really nice. It already does it for you. So these are all the connections that we need to put in order to do that this way. Okay. So here we're going to set DB7 to pin 2 right here. And I'm going to set this color to purple, just for fun. Yeah, make sure you leave, if you have any questions at all during this time, make sure you leave it in the stream. I can't see the live stream, but we have our officers watching the live stream and making sure that everyone can participate. And so if you have any questions at all, make sure you ask it in the live stream chat, and we'll get to answer your question. Okay, so yeah, so all we've done is connect this digital pin here on the Uno to the digital pin on the LCD. We're also going to connect D6, and this one I'm going to connect to pin 3. Okay, that's a little. And I'm gonna make this pink. The colors don't matter, they're just for your own differentiation. Then we're gonna connect D5 to pin 4 on the Uno. Make this turquoise. Then we're going to connect pin 5 to D4 on the LCD screen. Yeah, I'm only doing all this extra nodes of the wires, and you can make an extra node by just double clicking on the wire, and then that'll make an extra node for you to move around. I'm just making them to organize the board a little bit more, just because we're going to have a lot of wires going around. So I'm just trying to organize it. You don't have to do that, obviously. Changing the colors also helps, just so you can organize it a little better, but that's also not required. Okay, then we're also going to set our RS pin, which is this one, the register select pin. This one is going to pin 7. Let's change this color to brown. And then we're going to set the enable pin here to pin 6. So we'll have pins 2 through 7 all dedicated to the LCD and the different functions that go with it. And here you can see the wires can like cross each other and they won't overlap or mix, which is really nice. We'll set this to orange. Okay, so we have the first 6 pins of the LCD connected. We have the power and ground connected. Now we just need a few more connections for the LCD screen itself. So now let's set up the read-write pin. This read-write pin right here, we're going to set directly to ground. So let's go ahead and make a wire connected right here and change it to the color black so we can differentiate and double check that it's set to ground. Another pin that we're going to set to ground is this far LED pin, the LED cathode pin. Here's the LED anode pin. So we're setting the cathode pin also to ground. Oh, this one will just be fine too. Okay, and we'll set that to black as well, so that we know that that is going to ground. So yeah, you can see that this is what we're building. Basically, we're just setting up all of these connections here. Yeah, okay. So next one that we're going to put in is this resistor here. This resistor will change the value to 220 ohms. And this one is going to be going directly to 5 volts. And this will connect to our anode pin on the LED or the LCD screen. So we're just putting in a little bit of a resistor there for that purpose. Amazing. And then we'll set this to red. Going to that. Okay. Next, we need to set B0 pin here. This is the contrast pin. So the contrast controls how bright the screen gets, and we need to control this with a potentiometer. So we're going to connect this pin here to the middle leg of the potentiometer. Set that right there. Change the color to gray. Yeah, that is gray. Let's set that. Yeah. Okay. So that should complete all of the LCD connections that we have. And I'll wait a little bit so that you guys have time to catch up. Yeah. So TinkerCAD is really cool that it lets you simulate projects online and you don't need to have all the hardware. And it has a lot of things that you can use. So if you just look through the components here on the side, you can see that there's a bunch of different components that you can play around with. And they all have like pretty accurate changes, which is really cool. Like the photoresistor, when you run it during simulation, you can actually change how much light is going into it. And with that, you can change how your circuit reacts. So TinkerCAD is really cool for that. And then you can even write your code here in blocks form if you wanted to. I'm going to be writing it in the text form, which is the regular Arduino C code. Yeah. So it's really cool in that way. And then you can export your design as well. They don't have a way for you to import designs yet, but it's cool that you can export them. And they export as .brd files. And then you can also share your design with other people. Yeah, that's a little bit about TinkerCAD. Okay, so if everyone's caught up, go ahead and keep going. Now we need to connect all our LEDs. And this is going to get a little bit tricky because it's really tight here with all these LCD wires. Let's make a little bit more room. Okay, so actually, since we don't have enough digital pins, the RX and TX pins we use for transmission, and sometimes when you use those pins as digital pins, it can mess with the Arduino startup. So we're trying to stay away from those pins, which means we have 1, 2, 3, 4, 5, 6 digital pins left, but we have 9 LEDs. So an alternative to the digital pins, you can also use the analog pins on here, and you can write to them as regular digital pins, which is really cool. So we're going to be doing that. So we're going to use all the analog pins and then a few of the digital pins. Okay, so it's going to get a little messy. I'm going to move this button over here, just so that it's like a little bit clearer when I pull the wires over. But we're going to connect this anode leg of the LED to the analog pin here. So let's go ahead and connect this to A5. And I'm just making little nodes for it to look clearer. Okay. And I'm going to change all of these to blue. Oh yeah, so the little rocker game that we're trying to complete here, we're having all of these LEDs set to blue except the one in the middle. So how you change the LED color for TinkerCAD, it's pretty simple. You just click on the LED and you can change the color. So we'll set all of these to blue. Except for the middle one, which we'll keep that red. So let's keep going. Let's connect the next LED to A4 as the analog pin. Oh yeah, if you ever click somewhere on here and you have like a wire stuck and you don't know how to get rid of it, because it just keeps going, you just click escape and the wire will go away. That happens to me a lot when I'm using TinkerCAD.
Hey Mira, how do you how do you create a midpoint in the middle of a wire?
Oh, yeah, to create a little node like this, you just double click on the wire and it'll create an extra node right here. And you can use that as a degree of freedom.
Ah, okay. Thank you.
Okay. Yeah. You can also delete nodes just by clicking the delete key on your keyboard. That'll delete a node for you. So if you just click on the node, it'll light up and you can see the inside of the circle turns white and the other ones that are not clicked on will stay like the wire color. So if you just click on it, you can see that it's highlighted and you can move it around. And then if you double click on a different point in the wire, you can create a new node. Oh, I deleted the whole wire. Okay. Okay, we have two more here. Now really place these far apart. A lot of space. So I'm going to move these up here so that there's a little bit more space to see what's happening. Yeah, and this game is like a really fun, just kind of stress buster to play as finals are coming up because you can take your mind off of, exams and everything and just take some time to play like a quick game. And you can test your reflexes, which is really cool. Okay, so this wire, since it's connected to the red LED, I'm going to actually change it to a different color. So I don't want to use red because I've been using red for 5 volts. So I'm going to change it to white. Oh, actually, you can't really see that. Let's do. Oh, let's just do turquoise because it's like a special blue. Okay, connect this. A0. I'm going to move this button over just one more, just so that it's not interfering and you can see it, just so these wires are not like interfering with that process. And I'll change this color to blue. So right now I have the first 6 LEDs connected to all of the analog input pins. Next, I'm going to connect these 3 LEDs to some of the digital pins over here. So actually, the way you can use analog pins is as digital pins. So here, the digital pins go from 0 to 13. But then you start at analog pin 14 with, 14 with A0, and then you can go 15, 16, 17, 18, 19. So technically, you can use up to 19 pins on here as digital, which is really nice. But since I want them all to be in the same kind of order, like I have 14 through 19, I'm going to start with 13 here. So here I have, I have 14 connected to this one, so I'm going to have 13 connected to the next one. Oops. And let's change it back to blue. And the next one we'll set to pin 12. And this one we'll set to pin 11. Amazing. Okay, let's change these colors so that we know which ones are the LED wires and which ones are the LCD wires, so you're not getting any of those confused. Here we go. So those should be all of your connections for this project. So I'll just give you a moment to catch up. Leave any questions that you have in the YouTube stream so that we can get to answering them. Let me know if you have any questions, comments, concerns. Did I mess up a wire anywhere or anything? Yes, so go ahead and restart your YouTube stream. Okay, everyone. So we've also sent the sign-in link to the live stream chat. So if you need to sign in, make sure you do that. It's a simple Google form with like 4 questions. You just fill out your name, your email, and then there's some other follow-up questions. So make sure you sign that to get credit for coming into this workshop. Yeah, so go ahead and sign in using the sign-in link. Also, sign in even if you don't need credit for a class. It really helps us keep count of who's coming to these meetings and participating. And that way we can gauge more of an interest of what kinds of workshops to host, how we're doing. So all of that would be really helpful. So make sure you sign in to the chat. There's a link in the live stream chat. Kinds of workshops to host, how we're doing. So all of that would be really helpful. So make sure you sign in. So now that we've finished all of the connections, there's a link, and you've signed in, we can move on to the code part. So let's pull up this code window. You just click on this little code button, and the code window will pop up. If you have it on block mode, all you have to do is click this button right here. It'll change, and so you can click on text. We're going to be typing out our code today. So TinkerCAD has a really cool way for you to debug your code as well. That's what this little button is. So you can run the debugger, and the debugger will let you click on a point in anywhere in your code, and you can check what variable value that is at that time. So that's a really cool way for you to check through your code, and you can see where it's going wrong. You can also import libraries. So the libraries that they have are listed here. We're going to include the liquid crystal library. So go ahead and click include. All it'll do is click, it'll show this hash mark with include, and then the liquid crystal library. You can also just type that. Okay, and it'll do the same thing. So this is just a way for you to see what libraries they support. And then here you can download your code and share it and upload it to your actual Arduino. So after you've tested it out, you can download the code here, build this circuit in real life, and upload the same exact code that you're running here. And that way you can play around with it and test it in real life. That's really cool. Yeah, so we need the liquid crystal library. This is going to handle all of the LCD functions for us so that we don't have to worry about setting at every bit or every pixel on the LCD screen itself. So here it's come with code already. We don't need this. We're going to go ahead and scrap this. The two functions that you'll need are your void setup and your void boop. So setup is going to set up your all your variables, and boop is the function that the Arduino runs on boop. So that's going to continuously run. Once it reaches the end of the boop function, it's just going to start right over. So we're going to go ahead and do that. That's our main function, kind of. That's what's going to be running all of this stuff. Okay, so here, now that we've wired everything, let's go ahead and test some of these components out. So what we're going to do is start with testing the LED array. So we're going to create a static const int 8 array. I'm going to call mine LEDs, and this is an array of all of the pin numbers for all of the LEDs in the order that they are in the board. So here I want the light to move from this LED to this LED to this LED to this LED. So because I wanted to move across through all the LEDs and then bounce back going this way, I want to make sure that I have the correct pin numbers to activate those LEDs in that order. So here, my first LED is connected to, right over here, you can see it's connected to pin A5. So we're going to write A5 here. Then it goes down the line this way to the first 6. So A4, A3, A2, A1, and A0. Those are those first 6. Then this next LED here is connected to, I'll just move this over so you can see, we've connected this to pin 13. So here we're just going to write 13, 12, and then 11. So this is the order in which the LEDs are going across this way. So that we can see that order, we've just written it out here in this LED array. So those are all the pins that we're setting up. Now, in order to set up pins for Arduino, we need to set them up as output pins. So we're going to set a little loop here for our 9 LEDs. We're going to set them all to pin mode. Will be at I as output. So we're setting all of the LEDs in this array as output. So pin mode sets up the pin or the pin number, the little digital pin number at this value to whatever we've set here. And here we've set it as output. So we're having all our LEDs initialized here as output pins. Oh, I've forgotten a little parentheses. But yeah, we just set up a little loop to do that. Next, we're going to write all the pins.
Mira, so yeah, just really quick before we move on. So for your for loop, I think the I should be less than or equal to 8, because it just
You're
based on
right.
that. Yeah, so it would be doing.
Because there's 9 and we're starting at 0. Yes,
Yeah.
thank you. Good catch.
All right.
Yeah. The reason I started at 0 was because arrays usually start from point 0. So A5 would be the LEDs 0 in here. So that's why I started at 0. But I only have 9 LEDs. So we're going only up to 8, which will give us 9. Yes, thank you for that catch.
Yep, no problem.
Okay, so we're going to just start with a simple loop here. Let's use a different value. We're doing the same loop as the pin mode loop. But here we're just going to digital write all of the LED pins to low. So when we write an LED pin to low, that means we're turning it off. And then when we digital write an LED pin to high, here, I just put 0. If we write it to high, it's going to turn the LED on. So here's a simple loop. This is simply going to turn off all the LEDs. And then this one will turn on one LED. Okay, so what we want to start with is some simple code that is going to have us go through all of these LEDs one at a time. And then once it gets to the end, bounce back to the other side. So we want to start with some code that will do that for us. So actually here, if we want to test this out, we can set a delay for 1 second. So this is in milliseconds. So 1,000 milliseconds will give us 1 second. So if we start simulation, I think, oops, my bad. Should be, okay. Yes, sorry about that. So I spelled this incorrectly. Make sure you fix that. It's uint8_t. That is the correct variable title for this. Just make sure you change that. But here, all we've done is we've turned off all of the LEDs in a loop, and then we turn on the first LED, and then we pause for 1 second. And that's all this loop does, and that continues to loop over and over. So you can see that there's like no change happening because we have no delay between the lights turning off and on. So if we add a delay, sorry, you have to stop simulating in order to add more code. So here we stop simulating. So here you can see the light turns off and then on, off and then on. So that's just a simple test that you can run to make sure that your LEDs are wired correctly. So let's go ahead and take this out. Okay. So what we want to do is create a loop or create a function that will run through all of the LEDs one at a time, light them up, and then run back. So in order to do that, we want to have a variable. We're going to come up here and create a new variable called int LED position or pause. And we're going to set that to 0. So this is going to be the index of the LED array. And here's our LED array. So what this is going to do is it's going to mark the position of the active LED or the one that we want to turn on. So we're going to use that to mark that position. And we're going to start from 0, and it's going to end at 8, because we're going through our array of 9. Oh, that's not mean to open this here. Okay, so we're going to use this int to mark the position of the LED that we want to keep active. So we'll come back into our loop here. In addition to that, we want to know which direction our LEDs are going to be going in. So are they going from left to right or right to left? And to do that, we're going to put in a Boolean. And this variable is going to tell us whether we're moving right or left. So if it's true, we are moving from left to right. And if it's false, we'll have the LEDs moving from right to left. Okay, so here we want to set up a loop that will have us iterate through our all of our LEDs, and if they are at the LED position that we're looking at, or the LED position here, then we want to turn it on. And if not, we want to keep the rest off. So if the status is left to right, if we're going left to right, then we want the LED position to increment. We want to increment through this list. If we want if we're going from right to left, then we want to decrement through the list and go the opposite way. So we'll have the LED position decrementing. And we also want to check. So once we get to the very end of the list, we're going to want the LED to reverse. So we're going to want to start decrementing, and we need to change status in order to do so. So if our LED position light reaches greater than 7, which means it's reached the last one, which means it would be at 8. That means it's at the last one. Then we're going to go ahead and change status to false, so that it's going the opposite direction. And if it's not, then we're just going to continue as normal, and we'll increment this. So here's our status. This means the LED is moving left to right. And here, this means the LED is moving right to left. Yes, so once we've reached the last one, we want to change it to false. If we don't want to increment anymore, we actually want to start going the opposite direction. So we'll change the status to false. And then here, if the status is false, then if we've reached the first one is less than 1, so if we're at the 0, then we'll change status back to true. If not, then we'll just decrement the counter. So that is all that we've done there. So does anyone have any questions at this point of what we're doing? go ahead and leave those questions in the stream, and we'll be sure to answer those. I'm just going to leave some comments in here. Okay. So here we're keeping track of an LED position going back and forth through this array of LEDs. And as it goes back and forth, we can keep track of which light we're trying to turn on. And once it gets to the end, we can switch back and go in the other direction. So that is all that we've done so far with this block of code. So now we want to actually write that light to turn on. So here we're going to come down and here instead of LEDs 0, we're going to put the position marker and we're going to set that to high. So that way we can track through and see if this loop is actually working. So let's go ahead and test this. Oh, by the way, when you're running your simulation, you can test and change this so that the LCD will actually light turn on. Okay. So it looks like we've got some errors. So here, all of the LEDs are turning on.
Hey, Mira. So,
Yeah.
So I think the reason why all the LEDs are turning on is because right now we don't have a certain like interval set for each of the like lights to turn on or like stay on for a certain amount of time before
You're right.
changes, right? And so that's why. So it's like it looks like they're all turning on like at the same time, but they're actually just changing really, really fast. So like like I believe they're changing. Yeah, so it looks like they're all turning on at the same time, but they're just like it's just turning on really like blinking really fast. So they look like they're always on.
Yes. Okay, you're right. Sorry. So I forgot to add a delay. So you need this delay in here to show that the lights stay on for a little bit. So I'm just going to add this delay, and then now we can see that it filters through. Yes. Thank you, Alan.
Yeah, no problem.
So now you can see that the code is having the LEDs go back and forth. And so once it gets back to the beginning, it's going to bounce back and go in the other direction. Yeah. So that's what the delay helps with. Unfortunately, though, when there is a delay, you can't run any other actions, which means we wouldn't be able to press this button during the gameplay because the delay would stop all. It's kind of like an interrupt. So we wouldn't be able to run any functions. It would just be the Arduino would just be like holding everything for 1 second. And that's not how we want to play this game. We want it to continuously read for input so that whenever we click the button, it can understand that we've clicked the button. So what we're going to do is add a counter kind of. So we're going to come up here to all of our variables, and we're going to create a new one called previous millis. So we're going to keep track of how much time has elapsed so that when we know the time that has elapsed, we know when to change the light. So instead of having the delay hold the Arduino for us, we're going to manually do that. So here we're going to create a new variable called previous millis. I'm going to set that to 0 just to start with. And then we're going to come back down into our code. Oh, sorry. Let me just comment right here so that you can see. This will store the time of the last active LED. So we want to know the time that the last active LED was on and the time the current LED is on. And then we're going to subtract those two, and we're going to use that to measure how much time has passed. So we're going to come back down here to our loop. Right before the status here, we're going to create a new long called current millis. And we're going to set this equal to millis. So this is a function in Arduino that lets you get the time that has elapsed since this Arduino has been running. So once you start the code, it starts the counter, and millis will get you the amount of milliseconds that has passed since you've started the counter. So that is what this function will do, and that will give you the current time. So we're going to use that to track the current time. And we're going to use this to measure how much time has passed. So here, what we want to do is create another variable to measure the difference between them. So we're going to have another variable up here called the interval. And we're going to set that equal to 300 for start. So this means that our first interval will be set at 300 milliseconds. So after 300 milliseconds, we want it to change the light. Let's say if we wanted to change that to like the 1 second as before, we would just put 1,000 as our interval. Let's go ahead and set this to 300, and we're going to mark this as the current interval between the two times. We'll come back down here to where we declared sorry, you can see all of these together. We'll come back down here where we've declared our current millis. So we want to check and see if the current millis time minus the previous millis time is greater than the interval. We will use this to check if the time elapsed so this will tell you the time that has elapsed since the last time we hit a LED. And if it's greater than the interval amount of time, then we're going to go ahead and change the LED position number, and then we'll mark that. So all of this code will need to go inside of this if loop here. So all we need to do is delete this little parenthesis, and then you can highlight all of this code here. And then all I'm doing is clicking tab, and it'll indent it for me so that it all fits inside this if statement. And then I will close it with a closing bracket right here for this if right here. So this will tell me that only if we've elapsed the time within the interval, then we will change the LED position number, or we'll even check. We'll just only check only if the amount of time that we're trying to count has passed. And this way we can also change the interval time. So that means we can make each round faster, and we'll go into that a little bit more later. But yes, that is what we'll do then. And then after we've done this, right, if we've made this change, then we want to go ahead and set previous millis to equal current millis. So that will mark the previous time as the new current time, and then we can keep the count going. So to turn off all of the LEDs, so instead of having all of the LEDs turn on every single time the Arduino turns on, and like continuously bugging it, we're going to go ahead and put this inside this loop as well, so that we're only changing them when we have the current millis equal to the previous, or great, like when we've had the interval time elapsed. That's the only time that will change the LEDs itself as well. And then we're going to remove this delay since we've created a delay by doing this, by checking how much time has elapsed and making sure it's greater than the delay amount that we've set, which is this interval time. So just to check, make sure that that's working, let's go ahead and run this code. So here you can see we've set our interval time to 300 milliseconds, which is why it's going much faster. We can start at a slower time too. If we start at 1000, we'll set the same delay as before, and it'll be 1 second in between each flight. Yeah, and you can see it goes very slowly. Okay, so I'm going to stop here for a second, ask if anyone has any questions or needs me to go back to a certain part of the code, because I know I've been scrolling through quite a bit. So I'm just going to stop for any questions that you may have. I'll take this time to write some comments as well. Okay, so if there are no questions, then we're going to move on to the next part of this project, and now we're going to work on the button. So we're going to program the button in this TinkerCAD. So here in TinkerCAD, if the button is set to high, then it will read as pressed. So whenever we press the button digital pin will read as high. So here we have not set a digital pin actually for the button. So let's go ahead and do that first. Let's go ahead and set our button to pin 10 since that's available. So here we're going to take this terminal and connect a wire to pin 10. I can just go over everything. Yeah, let's just keep that at green. So that's our button, and that is set to pin 10. So here we'll come back to the code, and we're going to set a new variable. Let's come up here to where we've set our LED array, and we're going to set our button constant. So we'll make an int button, and this will tell us the pin number of the button. So here we've had an array of all the pin numbers of the LEDs, and now we have a pin number of the buttons. So we're setting all the buttons right here, and now we need to set it up in our pin mode. So we need to set up our button as input. And this makes for easy change. If you need to change your pin number, you could just come up here and change the number instead of having to go through the entire code and changing all of the 10s that are here. So here we've just created a variable called button, and we're going to set that as our input button because we're waiting for input from the button. Okay, now we'll come down to our loop, and we're going to do a simple if digital read. Now we do digital read for input pins. So if the pin at the button pin is set to high, that means the button has been pressed. So we're going to want to do actions when the button has been pressed. When the button is pressed, we want to know which LED we're at. We want to know if we've gotten to the red one or if we're at a different one. So to measure the red one, we'll come back to our array here, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 LEDs. So the middle one is going to be our red one. So the red one is set to pin A1 right here, and we can double check and make sure that that is true. That's halfway through the array. We can go back and follow this turquoise wire, and you can see that it's set to pin A1. So that is our position. So we want to see if our position number is equal to the middle one. Position 0, 1, 2, 3, 4. 4 is our A1 pin. If it's set to 4, then that means we've correctly clicked on the red one. So correct answer. And if not, then that means we've clicked on an incorrect blue LED. So we'll do other things for that. So that's whenever the button is pressed, we want to check whichever LED has been pressed on. And so we'll use the LED position variable to check which variable has been clicked on. Okay. So what we'll start with is whenever we click on the button, we're just going to start by decreasing the interval. So this interval right here, we set as our delay. So what we're going to do is we're going to come in here, and if we've clicked correctly, then we want to move up levels, which means the lights are going to move faster. So we'll set interval equal to, or you can do this, which is, it lets you divide and equal the number. So you can set interval equal to interval divided by 1.5. So this is letting us reduce our interval. And this means the LEDs are going to start blinking faster. And then if we failed, then we don't move up a level, so we're not changing the interval time. We also want to count the number of lives that we have and the number of levels that we are at. So we'll come back up here. So we've created our int interval. Let's create an int level. This will keep track of the number of levels that we have. We'll start at 3 levels. So basically, it keeps track of how many times we've changed the interval, and that can tell you how much faster your LEDs are blinking. And we'll have our int lives, and we'll set that to 3. We'll start at level 1, and we'll set our lives to 3. So we'll start at 3 lives. Keep track lives you have. So yeah. So whenever we correctly guess an answer, then we're also going to increase our level. which means the interval has gone up. But whenever we incorrectly guess, we're going to decrease our lives. So this is a short notation for you to be able to write lives or levels. Okay. Yeah, there we go. So this is going to just interval, and whenever we press the button at the red LED, it's going to determine whether we've pressed it at the correct LED, and then either increment our level or decrease our lives. So let's go ahead and try. I'm going to start at a faster interval just so we can see how it works a little bit faster. So you can see when I pressed on it at the red LED, it got faster. Yeah, it's just getting faster. Oh my gosh. Okay, and then I ran out of lives when I pressed it wrong 3 times. So that is how we did that. And now we have this little LCD screen, and we want it to show us, because keeping track of when it's getting faster or when we've lost a life is a little tricky. So we can use this little LCD screen to tell us when we're doing that while we're running our code. So now we're going to put in the code for the LCD screen. So let's go on up here. We're going to declare our LCD screen by doing liquid crystal. And then you can make any variable name. I've called it liquid crystal. So here you're setting your certain pin numbers. So whatever pin number you've set for your RS pin goes first. So your RS pin, for me, it's pin 7. Next, I set the pin number for the enable pin. So here it's 6. Then we have all of our digital pins that we're using. So we're using 7, 6, 5, and 4 of the DB pins here on the LCD. And those are in 5, 4, 3, 2. So we start with D4, and that is 5. So it all just increases. So that's declaring the LCD variable, and the liquid crystal library takes care of handling and instantiating all of that. So all we need to do is have this to declare the variable. And then to set it up, we have to come in here, set up LCD display. So we're going to set it up by doing LCD begin. And this particular LCD is 16 by 2, which means it has 16 boxes across and then 2 columns, or sorry, 2 rows. So if you pull up your components, you can see in the LCD, it tells you right here, it's a 16 by 2 LCD. Oh, I didn't need to add it. Yeah, so we'll come back to our code here, and that's all we're doing. We're declaring the number of rows and columns. Okay. Does anyone have any questions at this point, or need me to go back to any point of the code at this time? I will take a few minutes to just answer questions. Okay, so I just wanted to re-clarify that what we're doing right now, we finished most of the game mechanics. All we need to do is create this LCD display so that we can see what we're doing. We finished most of the game mechanics. We decreased our lives and increased our level. So now we're just setting up the LCD screen so that we can see a visual of that happening. Okay, cool. So let's continue. Okay, so we're going to do our LCD stuff. Let's go ahead and set up some stuff at the very beginning. We want our LCD screen to show us immediately off the bat, like, hey, you're playing a game. So here we're going to come up here. We're going to have it first print out the number of lives that we have. Okay, so what we've done here, all we've done is to create a display that is going to show us the number of lives that we start with and the level that we're at. So when we're printing to the LCD, all we do is lcd.print. Whatever your liquid crystal display variable name is, you're going to do that variable name .print, and then within the quotation in a string format, you're going to write whatever you want it to write, and it's going to automatically write that to the display for you. And here in the next line, what we're doing is setting the cursor to the next row. So here, instead of row 0, we're setting it to row 1, and there's only 2 rows in this display. So we have row 0 as the top row, and then row 1. So that is what we're doing here. We're setting it to the next one, and then we're going to have it show the level there. So we've just printed a level, and you can check that that works by starting your simulation. And here you can see that we have lives and level displayed. We haven't given it any variable name yet. It doesn't have any like value, but that's just how we're starting the game off. Okay, now we'll come back down to the loop here, and you can see that the lives and level are worked. So now we're going to continue and add some more mechanics to this. Okay, so if we've gotten the incorrect answer, if we've gotten the correct answer, let's start with that, then we want it to display that you're going up a level and that your number of lives is the same as what you had before. So what we'll do is we're going to set the cursor of the LCD to 10-1. 10 is going to give us position 10 of the 16 that are in the LCD top row. So we're going to position 10. And this just is giving us enough space to write after lives. You can also, if you set, this just gives us enough space after lives in order to set the variable. If you had lives right here and level up here, printed in this spot right here, you wouldn't have to set the cursor. All you'd have to do is print again, and it would print automatically after. But because we want to make sure that we're printing to the correct location, we want to set the cursor to 10-1. So we're showing that this is going to be incrementing the levels since we're in column 2. So here, indicate level up. So here, we're setting the cursor to 10-1, which will give us enough space after lives and levels, which will be the 10th spot in the LCD display. And we're going to set that to LCD print. So we're going to print a +1 to show that we've gone up a level. Then just to pause the gameplay a little bit, we're going to add a little bit of a delay, just so that stays for a little bit, and then we'll LCD.setCursor again to that same spot, and now we'll print the level number. So all we've done is indicate, hey, you've gone up a level. We're going to pause for a little bit. We're going to pause for 1 second so that you can catch up. Or here, let's do 2 seconds. And then we're going to print the level number at that spot again. So that's all we've done so far. That's what happens when you increase, or when you get the correct answer and you're increasing your position number, or increasing your interval amount. So let's go ahead. We start the simulation. You can see that it's going, and then if we press the button, pressed it incorrectly. If you press it at the red one, you can see it went +1, and now we have level at 2. Now you can see, obviously I didn't clear it correctly, so here we'll just LCD clear, and then we'll set the levels and lives again. Just copy this code down here. And fix the formatting. Okay, so this will just tell us, oh, we've gone up a level, we're going to pause, and then we're going to clear our display and then reset everything. So that will show the new level number, and you'll show that you've gone up a level. So let's go ahead and test that out. And you've gone up a level, and now you're at level 2. And you can see that the lights are getting faster. Okay, so that is what we're going to be doing for if we get it correct. Now, if we're getting it incorrect, we also want to decrement our lives and have the LCD display that to us. So here we'll go to the live section, or sorry, the else of the correct answer part. So this means we've gotten an incorrect blue LED that we've clicked on. So what we're going to do is set cursor to 10, 0. So we're going to indicate in the lives column. Okay, let me go ahead and move this after we've done live so you can see it update. Then we're going to print to the screen. A -1, so we can see that we've lost a life. Then we will put in a delay for 2 seconds, just so you can see that clearly. Then we'll go ahead and do the same thing as up here. We'll just copy this over here. We'll clear it, put in the lives, put in the level again. And now here, we're going to move this set cursor. We're going to move it to the lives spot. So in the lives area, we're going to reset the cursor in that same area. And now we're going to put the number of lives that we have left. So that can be shown. So let's go ahead and check this, see if that works. So if we press the button, our level went up. If we press in the wrong spot, our lives went down. Okay, we also wanted to print the level actually. So we're just copying this code back down over here. And we're having it print the level as well. So that is at the showing every time. We also want to know the number of lives that we have when we won. So we're going to move, we're actually just going to copy this entire block. It's the same code that we've written up here. I've just included another set cursor for the first one to show the lives. But actually, if I just copy this section, you'll see that. So this way, every time that we go up a level or every time we lose a life, we can see the number of lives and levels that we have. So let's see that. So I get it right, my level goes up, and you can see the number of lives. I get it wrong, my lives goes down. And if I get it right again, my level goes up. Okay, so we have that. But you can see at the beginning of the simulation, we don't have anything written on the screen. So we want to see all of this also at the beginning. So we're going to go ahead and set this up during our setup as well. So we'll copy this entire chunk of code that displays both our levels and lives. And we'll go ahead and put it in our setup. So at the very beginning, we can see all of this stuff. That is up there. So now if we start the simulation, we can see the number of lives and the level that we're at the very beginning of the game. And we have a little delay that is showing us how we're doing. Okay, now you can see if we run out of lives, it goes to 0, and then it just keeps going. So we need to set a loop in order for it to reset every time that we lose the number of levels and we end up at lives equals 0. So now that we've set all of this stuff, we're going to go ahead and come to the beginning here and set a new if. And if our lives is at 0, we need to reset all of our variables and start over. So we're going to set lives. We're going to set interval equal to, we want to set it to the same number that's up here. So 300. We're going to set our set a few more variables. We need to reset the level to 1. And then we'll reset lives to 3. Oh, typo. So this will start over the gameplay. So that'll start from the beginning. And then we'll update the LCD screen with all of this information by just copying that same code that we've already written. And this will just update. So this, if we are starting gameplay over, and then you just reset the interval, reset number of levels, and then reset number of lives, and then update the display. So let's check that and see if that will run. so that when we lose, it starts over. There we go. Okay. So that'll restart the game. We also want an indication that the game has restarted, like to say like, oh, game over, start over. So we want to include that as well. Let's go. Down here. So if our live is equal to 0, then what we'll do, we'll just indicate some more messages here. Let's set cursor. Okay, I'll do that. 0, 0. Here, all we're doing is adding some like end game messages. So once we've ended the game, we need to start over. And then we just set a delay here to display that screen so that we know when the game is over that it's over. So let's go ahead and test it out. So I just lost life, the level, lost life, lost life. So now it should say game over, start over, and it'll go back to level 1. So that's all that I have for you guys today. Now we've completed our entire game. So you can play this and see how many levels you can get up to. Let's see, actually, while you guys catch up, and if you have any questions, I'm going to just keep playing this game. Let's just restart. So if you have any questions, let me know. Leave it in the live stream. Alan is answering questions. Sarvan is also here answering questions. If you have any questions, let me know. But you can see basically we finished all the mechanics and we created this little LCD screen to show us that we are either losing lives or gaining levels. And it's just a fun game you can play to test your
Mira, can you show
Yeah.
people the LCD declaration at the top again?
Yeah. There you go. Right
Thanks.
here. You just set the pins based on what your RS and enable pins are. I'll go ahead and put in a comment of what they should be. There you go. So you can see which pin numbers you should put in for each of those areas. I've gone to like level 8 before, and it goes so fast that you can't, like all the lights look like they're on at the same time. Yeah, I'll scroll down so you guys can see the code as well. Or should I stay here? Oh, God. Oh my gosh. Oh, so sad. Yeah, if you have any questions or you need me to go over any of the code again, let me know. Okay, so let me just do a review of everything that we've gone over for today before we close off. By the way, we will put up the GitHub so you can access this code later and you can play through it. I'll make sure that we'll put in more comments so that you can follow exactly what's going on. But this live stream is also available for you to follow along at any time. Feel free to pause it and go through and follow me along. I know I started really fast and went through this pretty quickly, but there was just a lot of moving components. So I wanted to make sure we got through everything. So yeah, there will be a GitHub so that you can access the code later, and we'll make sure to post that into the Slack and possibly on the website as well. So let's go ahead and review. So basically what we've created is a game that turns on LEDs at different time intervals, and we want to be able to click the button at the same time that the red LED is flashing. So we start by setting up all of the components right here, and then here we've just created a display to start on the LCD screen itself so that we can see everything that's happening there. Here we've started our loop. So the first thing we did was check and see if the button is pushed. Then we check and see if the position is at the same as the red light, which is at position 4 or halfway through that pin array. So if it is, then what we'll do is decrease the interval time, which means we'll have less time in between each LED flashing, and we'll increase our level count. And then the rest of this is just some of the LCD stuff that we did, where we put in a display to show that. Next, if it's not at the correct LED, if we've clicked the button at a blue LED instead of the red LED, we decrease the number of lives. And here we've just set some LCD code to display that and update the lives and levels. Down here is our loop, or our counter that is checking to see each time you run the loop, the Arduino loop, it is checking to see what time it is and how much time has passed since we lit up the last LED. And we want to make sure that we're measuring above that interval time so that we don't change the LEDs too early and we can keep in a delay. So this created a kind of like manual delay. Down here, what we've done is we are checking which direction the LEDs are going in. So if they're going from left to right, then we want to increment the position counter. And once we get to the end, we want to switch directions. So we change the status to the opposite value. Down here, what we do is if they're going from right to left, then we want to decrement the position value through the array. And if we've reached the very last one, then we want to switch directions again. and then start incrementing again. And then down here, all we do, this is where we're actually turning on or turning off the LEDs. So we set all of them to off just to make sure that none of them are staying on from the last time. And here we write the one LED that we want to turn on to high. So that is all that we've gone over today. Make sure you leave any questions that you have in the YouTube live stream. Yeah, that's it. I hope you guys enjoyed. Make sure you sign in at the sign-in link. The sign-in link is also at the YouTube live stream. It's in the comments section, so make sure you sign in. It helps us keep track of numbers, and you'll also get credit for your classes if you make sure to sign in. And that is it for today. So thank you all for joining. Leave some questions. We're going to leave the stream going for a little bit so you can finish all your questions. If you guys are done with the project, we'd love to see like videos of you guys because we can't see you in person. So if you want to like send in a video of yourself doing this project, or if you actually implemented it in real life instead of just on TinkerCAD in the simulation, we'd love to check that out too. So share that if you have that. Okay, everyone, thank you for joining. If you have any more questions, feel free to reach out to me, Mira Jambasaria. I'm in the IEEE Slack. Also, Alan Liao, he's been answering questions in the stream as well, so feel free to reach out to us. If you have any questions, if you had any comments about this workshop, we'd love to hear that. If we were going too fast or if there were any audio problems or anything like that, just let us know. Thank you guys so much for joining. I hope you guys are safe and healthy and happy in these times. Okay, thanks everyone.